into your head. This needs to be second nature after a while. So what is the probability of selecting a woman whose height is over 66.5 inches? 0.21, so 21% of the time. I'll randomly select a woman over, that's 5'6.5" Okay, that's not particularly unusual. Not unusual to get one single woman that's over 5'6.5". Okay, but now since we're looking at sampling distributions, let's go get a sample. So we have our sampling distribution on the board, and we did sample sizes of 10. So now I'll ask a different question. What's the probability of a random sample of 10 women having an average height over let me go with my 66.5 inches. Jeez. There we go. Okay, so do you think that's going to be a little more unusual to find a group of women who whose average height is over 5'6.5"? Unless you're getting a basketball team, yeah, that's then. But so this probability should be smaller. Okay, so let's think of the distribution. The distributions of women's heights is normally distributed. So the distribution of the sample of size 10, sampling distribution, has the same center of 64.5 inches. But the standard deviation is different because I have a larger sample. My standard deviation for this sampling distribution, so I'll say standard deviation of x bar, is going to be the population standard deviation divided by the square root of the sample size, which is approximately about 0.8, 0.79. Close enough? Okay. So now I still want to think of this 66.5, but that's going to be an average height. I'm going to shade and see if I can shade. Yeah, okay, that works. Still looking for over 5'6.5" inches. So I need a z again of 66.5 minus 64.5 divided by my new standard deviation, and that z is can you do that one in your head? Yeah. 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 All right. That z tells me I am I'm over 2.5 standard deviations away from the mean. That's the z-stores give me. They tell me the number of standard deviations I am above the mean. Can you guys stay with this? Okay, thanks. All right, so now I need my probability that my sample of 10 women has a height greater than 66.5, which is the same thing as the probability of my z being greater than 2.53. You should do another normal CDF calculation. Or you can look this up on Table A. You'll have to do a complement because Table A gives you less than. So you don't have to write anything because nobody cares whether you got this probability, this proportion from Table A or from your calculator. Nobody cares how you get this number. So you just write out probability Z greater than 2.53. That's all the work you show. Unless you're going to integrate this by hand, but then you're not. Why do they keep saying that? Ask me if I want to change my color thing. Jeez. Guess it doesn't like my colors. What do we got for our proportion, our probability? 0.0057, so I'll call it 0.006. So that means that 0.6% probability of selecting a random sample of 10 women whose average height is greater than 66.5 inches. Okay, a lot smaller, a lot more unusual. 21% for just one woman to get a sample, to just get a single person. 0.6%, less than 1%, to get an average on 10 women to be that high. Okay, so this is where we're going with the